Hey everyone, and welcome. Today, we're diving into something that sounds almost like science fiction. It's a new framework called Agent Lightning, and it makes a really bold promise. What if you could teach any AI agent how to learn from its mistakes, on the job, making it smarter and more capable without you having to do a ton of extra work? So how on earth did they pull it off? Let's find out.
But first, I've got to ask, especially for all you developers and tech leads out there, just imagine this. What if you could take that agent you've already spent weeks or months building, doesn't matter what framework, and just give it the power to improve itself, all on its own, without you having to go back and re-engineer the entire thing from scratch? I mean, that's the game-changing idea we're really digging into today.
Okay, to really get why that promise is such a big deal, we need to talk about a pretty frustrating reality. For all the amazing things AI agents can do, most of them right now are, well, they're kind of stuck. They have some really serious limitations holding them back.
So here's the thing. Today's agents are often what you call brittle. They're awesome at the one specific thing they were trained to do. But you throw them a curveball, a new situation they haven't seen before, and bam, they often just fall apart and make a mistake. And the more complex the task, the worse this problem gets. Now, the usual fix for this is, well, it's just more and more supervised training, which is incredibly slow and super expensive. But the real core issue here, they're just static. They don't have a built-in way to actually learn from their own experiences.
All right, so how have people been trying to solve this up until now? Well, the traditional approach to making these agents smarter has been, let's just say tangled is putting it mildly. Frankly, it's been a mess, and a lot of the time, it creates even more problems than it solves.
See, the old way basically forced developers to cram all the training logic right into the agent's own code. It creates this messy, what we call tightly coupled system. And that analogy of trying to upgrade a car's engine while it's still welded to the frame, that's perfect. It's a nightmare. What Agent Lightning does is just completely separate the two. A clean break.
And the researchers behind Agent Lightning said it best themselves. Their whole goal was, and I'm quoting here, complete decoupling with almost zero code modifications. Just let that sink in for a second. Zero. This isn't just a little step forward. We're talking about a completely different way of thinking about how we build and train these agents.
So yeah, this is it. This is the central idea, the big aha moment behind Agent Lightning. It's this absolute breakthrough concept of decoupling. So let's pull back the curtain and see how it actually works under the hood.
So how in the world did they pull off this clean separation? Well, the trick was to treat any agent's workflow like it's a game. They used this mathematical framework, and don't worry, it sounds way more complicated than it is, called a Markov Decision Process, or MDP. Just think of it like a universal translator. It doesn't matter what the agent is actually doing, its actions can always be broken down into a sequence of states, actions, and rewards. Just like moves in a board game.
All right, so that's the big idea, the theory behind it. But what does this look like in the real world? How does it actually work? The system itself is actually pretty clever and elegant, so let's break it down.
The whole thing really comes down to three main steps. First, just like we said, it frames the agent's job as a game using that MDP model. Step 2, it just sits back and watches. It observes the agent playing the game and records everything it does. And then step 3, this custom algorithm they built, called Lightning RL, steps in. It acts kind of like a coach. It looks at the results of the game, figures out what were good moves and what were bad ones, and then rewards the agent for the smart plays. And that feedback loop is what helps the underlying AI model get better and better. Now, from a technical standpoint, this is all run through something the paper calls training agent disaggregation. Basically, it's a server-client setup. You've got this powerful Lightning server that does all the compute-intensive stuff, all the heavy lifting of the actual training. And then on the other side, you have a tiny, lightweight Lightning client that just runs with your agent, watches what it does, and sends that data back to the server. The key thing is, the two are totally separate. They don't interfere with each other at all.
Okay, but look, a great idea on paper is one thing. The real question is, does it actually work? So, naturally, the researchers put Agent Lightning through its paces, testing it on a whole bunch of different tasks to see if the theory held up in the real world.
And they didn't mess around. I mean, look at the variety here. They tested it on an agent built with LangChain that had to write SQL queries. Then another one using the OpenAI Agents SDK to do complicated research tasks. And even another one using AutoGen that solved tough math problems with a calculator tool. We're talking about some of the most popular real-world frameworks out there today.
So what was the final verdict? The bottom line is, it works. It really works. In every single test they ran, the agents trained with this system showed steady, continuous improvement. They literally got smarter, more accurate, and more reliable the more they worked.
Okay, so we've got a really powerful idea, and we've got the proof that it works. So what does this all mean for the future of AI? Well, if you have to boil it down to one word, it's this: adaptation. The future of AI is adaptive.
But before we get too far into the big picture, I want to bring it back to just one number: 0. That is the number of code changes you need to make to plug this into an agent you already have. Just boom. Suddenly, the single biggest roadblock to creating agents that can actually learn and improve on their own is just gone.
For developers, this is absolutely huge. It means you can now train any agent you've already built, no matter the framework. It means you can finally stop that painful, soul-crushing process of rewriting your agent's logic just to fit it into some complicated training system. It means you can go beyond these static, one-and-done models and create agents that are truly adaptive, that learn and evolve from real-world feedback. And you can collect all this amazing, diverse data from how they interact with the world to make your base models even better.
And all of this really leaves us with one last, really big question to think about. For what feels like the first time, we have a real, practical way to let pretty much any AI agent learn from its own experience, the same way we do. So the question is, if they can learn like us, what problems that seem impossible today will they be solving for us tomorrow?